Hello. We're going to talk about rolling motion. This is also called rolling without slipping. So in Chinese, this is 滚动. And this one here is 滑动. Okay, so that's our topics. And we're going to use bicycle wheel as an example. So a bicycle wheel, you're going to break it. So you're going to break the bicycle, break a bike's wheel, right? Bike's wheel motion into a pure rotation. So here's a pure rotation. So imagine that you have this wheel and it's only rotating around the center here. So then I'm going to change in color here. So then you will have your velocity the same at every point. Okay. And at this point, you are rotating with the angular velocity. So this V is equal to R omega everywhere. Right? So V is the same. So pure rotation, and it's a constant speed, pure rotation, right? So omega is constant in this case. Okay. Of course, pure rotation can have a changing omega too, right? But in this case, we assume this is constant. Okay. And then the other part, right? The other part is pure translation. So what do we mean? So we have this, the wheel, right? I'm changing color here. Okay. So every single point, you're going to have a velocity. Okay. Say they are the same, for example. And this point will have a velocity that going this way too. Okay. And that point too. Okay. And this V is equal to that R omega, but now it's having a constant linear motion. You see that? So this is called pure translation. Okay, every single point, including that one too, right? It's all the same wherever you go. Okay. Now let's look at a few points here and add them together. So let's look at this point here and that point. Okay, so if we add them together, that's going to be equal to, make this circle here. Okay, so pure rotation and pure translation. Let's look at this point here. So this is 0, right? So there's no velocity right there. Velocity is equal to 0. So you add these two together, now you have, I'm changing color again. You have this one here as V, okay? And now if you add this point here, for example, right? This point, he's going this way, but he's going that way, right? So then they cancel out. So this one here, velocity is equal to 0. Okay. Now if you look at this one here, let's make that one a circle, for example. Circle there, right? Then this one's V, but that one also V. So this is 2V. Okay, 2V. All right. And change color a little bit, so make it a little bit more interesting. So in this one, pure rotation at this point, I'm gonna make that one a triangle, right? So this one goes up, but this one goes to the right, okay? So we're gonna have something that goes like 45 degrees, right? And this one here will be square root 2 v, right? Okay, it's going that way. And this is, at this situation, this is 45 degrees. And how about that one there? So this one here, this is going to the right, and this is going downward, right? So obviously this one, it's going to be going this direction. Okay, and that's square root 2 v also, and that's also 45 degrees. So you can see, right, you can go and do this for every single point. And so this one here, it's bike's wheel if there's no slipping, okay? When there's no slipping and it's rolling, okay? And then it's translating, but at this point here, there's the contact, right? This is so-called the contact point with the ground, right? Contact point with ground. The velocity is equal to zero, right? Okay, so that's the rolling motion for a bike's wheel. Okay, and it's a rolling without slipping. Okay, we're gonna stop right there, and we'll give you a chance to think about it, to reflect. All right, so we'll see you